classes of basic electronics. We are going to discuss about special purpose diode part 3. In this topic, we select few special purpose of diodes. If you haven't seen special purpose diode part 2, you have to click on this I button. Now don't waste time here, let's start with today's outcomes. These are the today's outcomes. We are going to discuss about first photodiode, then after 7 and 16 segment display, and last we are discussing about dot matrix LED display. In photodiode we are going to discuss about its symbol, operation and characteristics. 7th and 16th segment display we are going to discuss about construction, working along with its application. Final, in dot matrix LED display we are discussing about its working, circuit and its application. So let's start with photodiode. So photodiode is basically similar to the solar cell and it is also similar to the LED. Here we can see this is the symbol of photodiode. It's slightly different compared to the LED. In LED we have seen that this arrow's indication is outside. But here in photodiode its arrow's indication is inside. That means it absorbs light, whereas in LED it emits light. So this is the difference between LED and photodiode. Now solar cell. Solar cell is quite similar to the photodiode because in solar cell we have discussed about it that solar cell accepts photon or light energy, and through these photons in circuit diagram we can see the flow of current. Similarly here in photodiode it will be happening but in different manner. Now let's start with photodiode. Photodiode is constructed with the help of silicon and germanium material. It is packed in a plastic capsule. Here we can see this is the actual appearance of photodiode. It is in plastic capsule and its upper side is totally transparent because your light is emitted through this upper side. So one end of lens is formed such that light is focused on the junction. So it works in reverse biased. If it increases, minority carrier charges also increases. On the top of metal case, there is transparent window where light is striking. We can say which allows light to enter up to the PN junction. So let us discuss about its working principle, how it works. So here we can see when diode is working in reverse bias condition, then reverse saturation current flowing through it from positive to negative terminal of the diode. Now I am going to discuss about reverse biased condition. That means its width, its depletion width is larger, it's wider compared to the forward one. That means depletion region is spread in P-type junction and N-type junction. So here, if at this particular time, when light is struck on this depletion region, at this time, electron-hole pair is generated. When this electron-hole pair is generated, it moving towards positive to negative terminal respectively according to its bias. That's why current is flow at this time. So like this photodiode is working. Here we can see photodiode we do same control the conductivity of the device. As the name suggests, in the photodiode the PN junction gets exposed in the light. Depending on the intensity of light, its electron-hole pair is increased. When its electron-hole pair is increased, that means photocurrent is increased. That means intensity of light is directly proportional to the photocurrent. If intensity of light is higher, that means your photocurrent is higher. So at this can say photo current is flow from this circuit diagram. Now, according to this, one question may be arise in your mind that why it is working in reverse bias, why not in forward bias? It is working in reverse bias, that's why if there will be slight change in current, so it is noticeable, because in reverse bias the current flowing in microampere. If we strike a light on that PN junction, so it is minor changes and we can notice it, that current. If it is working in forward bias, then forward current flows always in milliamps, or we can say milliampere. And due to this, we cannot measure or notice that current in absence of light. Due to this reason, it is working always in reverse bias condition. Other than, what is dark current? Dark current, that means when there is an absence of light, there may be a flow of current, which is also known as reverse saturation current. It is due to the minority carrier charges. And if your temperature is increased across this junction, that means your minority carrier charges also increased. So that is known as dark current. When there is absence of light, your current may be arise. So this is the all about photodiode. Now let us discuss about its application. Photodiode is most important in optical fiber receiver. Well, we know the optical fiber where light is emitted from transmitter to receiver end. At the receiver side, we have to connect photodiode that senses this light and decode this signal. Also, it is used in cameras where it senses lights. So these are the application of photodiode. Now let us discuss about 7-segment display. Now we all know about display which are available around any clocks, calculators and digital characters representation. So here we can see this is the 7-segment display and this is the basic display among this segment. Here we can see 7 segment, that means A, B, C, D, E, F, G. There are 7 different types of segment which combines or which represent numbers 0 to 9. So it is known as 7-segment display because it represents 0 to 9 numerical numbers. 7-segment displays are 2 different types of. Number 1, common anode type, and number 2, common cathode type. Here we can see the circuit diagram of common anode type. So this is the common anode. That's why here we can see there are various types of or different LEDs are connected. At the anode side, it is common, which is connected to the main supply, or we can say power supply, and its cathode is open, and in between cathode and anode there is a LED which emits light. So here we can see in common cathode type display, anodes of all the segments are, and decimal point, which is also represented here, DP. It is manufacturer LED. Manufacturer LED decimal point are joined together and cathode leads brought out. To excite the particular segment, the common lead is connected to the positive supply. And it's another segment, or we can say it's another lead, which is cathode. It should be connected with the resistor and ground. For example, if I have to represent here number 1, so B and C. Here we can see in this B and C segment, it should be connected to the ground, and remaining all are not connected to the ground. So here we can see B and C is connected with the ground. That means current always flow anode to cathode. That means anode to cathode. So it emitted light at the B and C. So it represents number 1. So like this manner, it represents 0 to 9 numbers. More display is available here. It is the 16 segment display. It is an extension of the more common 7 segment display or 14 segment display. By adding 4 diagonal, here we can see 4 diagonal and 2 vertical segments, and by splitting the 3 horizontal segments into the half, it displays alphanumerical characters. So this is the extension version of the 7th and 14th segment display. If you want to display alphabets along with numerical characters, then you have to try 16 segment display. Now next topic is dot matrix display. Dot matrix display LED display contains the group of LEDs as a 2-dimensional array. There is a big problem to use driver for each LED. Therefore, we are going to use dot matrix display in sequential manner. Display various types of characters or group of characters. Segment of LEDs in a metric pattern is made up in 2 ways. Row anode, column cathode, and row cathode, column cathode. So in this 2 manner, we can connect LEDs. There are various types of dot matrix are available: 3 by 5, 5 by 7, 9 by 5, 7 by 9. If you interested to display alphabets and numerical characters, then you have to try 5 by 7 dot matrix display. If you want to display only numerical character, then you have to try 3 by 5 display. Here, by using dot matrix, we can reduce the number of pins required for the controlling all the LEDs. So anode of each LED are connected together in the same column, and the cathode of each LED are connected together in the same row, or vice versa. Here is the example of 5 by 7 dot matrix LED display. Here we can see these are the row, and above we can see is the column. Here it is represented in R, here it is represented in column. Now it is row here and column in this manner. So it is known as 5 by 7 because here we can see it is 7 and here 5. So the array consists of 5 column connectors, each connecting the anodes of 7 LEDs. Each row connects to the cathodes of 5 LEDs. To turn on particular LED, power is applied to the column and its row is grounded. So like this manner, we can represent alphabets and numeric characters together. So it is also used in calculators and clock and many more devices which represent digital numbers and alphabets. So that's all for today's lecture. If you have any query related to this topic, you can mail me on this email address. Till then, keep reading, keep learning. See you soon in next coming lecture. Thank you.